Hey everyone and welcome back. In today's video we are exploring the fundamentals of Versa Secure Software Defined Wide Area Networking or SD-WAN, a revolutionary approach to network connectivity that's transforming the way business manage their networks. We'll also walk you through a demo of the Versa SD-WAN solution. Myself Vignesh Pandarangan and I'm from the Calculus Global Engineering team, where we are responsible for building different vendor services as products within the organization and then enabling different verticals within our organizations for pre-sales, post-sales support, etc. as needed. Right. Also today I have with me my colleague Mr. Rahil Rahman, and he is also part of our Calculus Global Engineering team. For today's agenda, we'll start off with a quick glance into Versa. Followed by that, we will talk about different components available in Versa Secure SD-WAN and about the Versa SD-WAN control plane, data plane, and finally we'll wrap up things with a demo session. Versa has built a robust platform that converges both networking and security. With this, they offer a solution to connect branch offices, home offices, or users anywhere, everywhere to applications, basically irrespective of their geography. The Versa Secure SD-WAN platform is delivered in different modes, as a cloud service by Versa themselves or in a cloud hosted and managed by Versa authorized partners, or if as per the need, it can be on-premises or hybrid as well. The first component we are going to talk about is Versa Director. It provides a single pane of glass management for the whole Versa Secure SD-WAN overlay. The Versa Director have multi-tenancy and role-based administrative capabilities, with which we should be able to scale to many end customers and organizations as we need. Any configuration inventory, real-time monitoring, OS or patch upgrades, and even accessing the analytics platforms for historical reports and data can be handled from this Versa Director itself. So for any day-to operations, an administrator can only log into this Versa Director and should be able to do any tasks required. The next component we will look at is Versa Analytics. The Versa Analytics is a rich, near real-time big data solution which can provide visibility and control, baselining, correlation, prediction, and feedback loop into Versa solutions. It also provides near real-time and historical search reports on usage metrics, performance metrics, trends, security events, and alerts as well. If we get a level down, the Versa Analytics have different personalities. The analytics personality, the search one, and also we have a log forwarder and collector personality. A standalone Versa Analytics node can be enabled with all these functionalities, but in general, based on the size of the deployment, there will be a cluster of analytics built with separate nodes having separate functionalities, which we have just discussed. Versa Analytics is multi-tenant as well, which gives flexibility to deploy a single cluster and provide service to hundreds of customers. Right? You don't need to deploy separate analytics for each and every customer. It is tightly integrated with Versa Concerto and Versa Director for complete role-based access control, meaning as we discussed in the Versa Director section, we can access the Versa Analytics and manage it completely from the Versa Director itself. No need to log in directly or separately into the platform, right? Analytics platform. In other end, we also export the logs in different formats as needed from the Versa Analytics, rather than exporting it from every edge routers. The log format can be as a syslog or IPFix, right, which makes it compatible with the existing SOC solutions as well as our NMS solutions as needed. And obviously, the analytics is extensible and flexible via REST APIs as well. Next, the Versa Controller. The Versa Controller is one of the critical components of a Versa SD-WAN solution. Any new edge routers that are being onboarded will try to establish a secure channel with the controller, and then from there they should be able to reach the director to get the complete configuration. You can say that the controller also acts as a VPN concentrator and route reflector that provides secure connectivity from branches to the head-end nodes. And it also acts as a control plane backbone for exchanging real-time reachability, route, topology, performance metrics and SLA informations between the branch offices. All can be done via the control plane, the controller. Next is VOS, the Versa operating system. It is a cloud native multi-tenant. That is one key factor to remember. It's multi-tenant. The edge router itself is multi-tenant in Versa. Everything is multi-tenant capable in Versa. And also it has a full set of networking capabilities, including SD-WAN and advanced routings, along with huge security functionalities. When I say advanced routing, it is service provider grade routing. The Versa operating system can be installed on any x86 platform. It is a white box solution. Though there are certain white box vendors who are already certified by Versa, also Versa does have their own hardware router as well. The Versa OS supports standard protocols and log formats, including syslog, IPFix, SNMP, and netconf, which makes it compatible with any NMS systems. As we discussed previously, these VOS enabled devices can be automated and centrally managed from either Versa Director, or if we have a Concerto deployment, can be managed from Concerto as well. And we utilize workflows, template-based configurations in these platforms to manage a big scale of edge routers. Also, the VOS have a capability to host third-party VNFs itself. So you can consider the Versa router, edge router itself as a UCP. You can think about Versa Concerto as a component which runs on the top layer of Versa Director, Analytics, and controller elements. This provides an easy to use single pane of glass based management for connectivity and services. In the backend, it uses RESTful APIs and Kafka event streaming for communication with the network management elements. And the Concerto is built based on microservices architecture and is designed to run on public or private clouds. And this makes horizontal scalability easy and flexible. What will be the main push for deploying Versa Concerto when you already have the director who's doing the business for you? One, when you need a complete SASE solution, which is SD-WAN with SSE. Another one is when you want to manage multiple instances of director, analytics, and controller. Right. So, example, you have multiple set of headends deployed, and you would like to manage all of them from a single place. Then Concerto comes into picture. This is more relevant to the service providers. Also, Versa Concerto provides multi-tenancy, role-based administrative capabilities, which makes it easy for you to manage and control each tenant sites and services as needed. In general, we call the Versa Director, Analytics, and Controller, and optionally the Concerto, if we have the Concerto, as the Versa headend, which manages, monitors, and orchestrates the complete SD-WAN overlay. All the edge routers which run the Versa operating system first need to establish a secure channel with the controller for communicating securely with all other components in the headend. This communication between the edge routers to the Versa controller will be IPsec based tunnel, and the VOS will know about the controller details automatically via ZTP, or there is other means as well, such as URL based onboarding, etc. Once this secure channel is established successfully and the edge router have got all the required configurations, policies, routes, data plane IPsec essays, etc., the edge router will move to the next phase of establishing secure data plane tunnels. You have to note that the IPsec tunnel being created from the edge routers to the Versa SD-WAN controller goes through both phase 1 and phase 2. As we discussed in the last section, once all control channels, configurations, policies, routing, IPsec, and all other details are received successfully, the SD-WAN edge router will start to form an IPsec tunnel with the other edge routers in the overlay, right, based on the design which is configured. Say if it is a hub and spoke topology, it forms data plane tunnel with the DC and DR routers, whereas in a full mesh setup, the data plane tunnels will be formed with all edge routers available in the overall network. To be specific in Versa, we have an option called hub and spoke only in which the tunnels are formed only with the hub and only hub routes are advertised to the branches. And the other option is spoke to spoke via hub, in which the tunnels are still only formed with the hub locations, but the other spoke routes are shared with all other branches with the next stop changed to be the hub. And if you configure it as full mesh, tunnels will be formed directly between all branches and hub locations. Also, routes will point directly right between each branches and between the hub locations. The key point to note here is the data plane tunnel is IPless, meaning it doesn't go through IPsec phase 1. Since we are already having a secure control channel built with the Versa controller, and all the edge routers are also connected to the same, the IPsec details are communicated via the Versa controller. Also, there is by default SLA being monitored via every transport between the edge routers, where the values of loss, latency and jitter are collected as well. Finally, once the data tunnels, routes, policies, everything is in place, the data traffic will also start to flow between the sites. Let's have a quick introduction to the template architecture of Versa SD-WAN. Versa SD-WAN solution have a great template architecture where sites with similar designs and configuration requirements can be assigned under a single template. Say assume we have a design where we have 3 types of sites based on their design, right? The branch, stores and one for DC. Irrespective of the number of sites, say all branch locations can be assigned to the same single branch template. Same applies for stores and other types of sites as well. Just in case there are 20 branches where 10 branches are of one design and other 10 are in another design, we can create 2 separate templates. Example, branch template type 1 and branch template type 2. These templates in Versa are called as device templates. Also, say if an organization have common settings which are similar throughout the organization irrespective of the design. Say for example, TALX, NTP server configurations. In those cases, we can create a new type of template called a service template for the QoS, TALX or NTP, whatever. And then bind this template into the specific device templates who all needed that. In case if it is for the complete overlay, it should be applied to all the device templates. So when the final template is converted into configurations and pushed into edge routers, the QoS and NTP configurations can be maintained identical throughout the complete overlay. Also, in regards with variables and constants, there are certain parameters within a template which can be constant, meaning this value is pushed to all the devices attached under the same template, whereas variables are parameters which could change in every site under the same template. The Versa director will probe the administrator to fill the values for all variables which are available in a template. This is called as bind data in Versa. And the Versa director will again combine all the templates, constant, variable values, everything, right, before preparing the final configuration which needs to be pushed to the edge router. Here is the topology which we will use for today's demo. If you can see, this is a simple topology where we have a DC location with a standalone Versa CPE behind which there is a server. In both branches there is only one SD-WAN router with a user machine behind them. All the SD-WAN routers in the lab are connected to both MPLS and internet circuits where the Versa headend is only reachable via internet transport. All the SD-WAN edge routers will establish secure control channel to the Versa headend via the internet path, whereas MPLS path will be only used for data plane communication. Now let's start the demo. I have Mr. Rahil here who will walk us through the demo part. Over to you, Rahil.
Now moving forward, so I'll be responsible for showcasing you all the demo to cover up the basic use cases of the Versa solution. So we have built a simple lab, so where we have a Versa director, Versa controller, and Versa analytics, right? And we have a basic branch topology. So we have hub and few branches, so with which we are going to showcase you all the demo. Okay, so we have the Versa director here. So Versa director basically is an orchestrator, right, which manages the templates, branches, users, everything. So this is the GUI of the director. as Vignesh mentioned in the presentation, right? We have the director, so we have the analytics which takes care of the logging, the reporting part, and everything. The controller. So this is a controller that we have in the lab environment, which takes care of the control plane. We've already like onboarded two branches. So one is the hub, the other one is the branch. So that is already onboarded into the Versa director. Now what we are going to do is, so we will be onboarding the second branch, right? As per the demo topology that's been showcased, right? So we're going to onboard the second CPE. Before onboarding, we are going to talk about templates. Templates is very crucial or basic step for the configuration part, right? So for the Versa director to know about the device, we would need some information about the device, the serial number, how many WANs it's going to use, what kind of WAN it's going to use, how many LANs it's going to use, the IP address of WAN, so everything, right? That templates we're going to create it in workflows. So this workflows is the first step before onboarding we are going to do, right? So we are going to go to that workflows templates. Template is the column where we are going to create templates for the branch, right? So we have two templates already. So one is the branch template, the other is the hub template, right? So um, there will be CPEs or branches which will have common configuration or the same configuration. So in that case, we can use the same template for multiple devices. That is also possible. So we have like three appliances, but we have two templates here. So what we're going to do is we are going to match the hub template with the hub device. And this branch template will be associated with the two branch appliances. So we've already onboarded one branch appliance already. Now we are going to like onboard the second branch. So we have already created a template, but I'll just walk through what a template consists of, right? So if you see, when we try to add a template, create a template, right? So this is the first tab so this is like the basic step where if you want to make the branch, right, make the CPE as a full mesh or a hub or spoke, we can configure accordingly according to the customer's requirement. And this subscription is the license with which the customer has acquired, right? So what kind of license he has acquired? So the service permit, the license year, right? How many years the license valid? So it's valid, correct? And then organization is nothing but the tenant organization, the customer organization that will be mapping it here. And then we have the controller. So for this particular director, we have the demo controller as its controller. So we have mapped that as well. So this is the basic post staging template, right? So the next one is the interfaces. We can mention or so for that particular appliance how many WAN interfaces we need, how many LAN interfaces we need, that we can specify it here. And then kind of network that WAN belongs to, whether it's an MPLS, LTE, internet, that will be able to specify it here in the network name. And then we have the IPv4 address, whether we need to configure a static IP address or if it's a DSCP address. And then we have the LAN interface. We'll specify that particular interface as LAN, and then we'll be giving it a network name and then the routing instance. So the routing instance here refers to a VRF, right? So in Cisco we have VRFs, right? So similar to that, each network would be belonging to a routing instance. So for example, so this VNA 0/0, right? So we have the MPLS, so it will belong to MPLS VRF. And then this VNA 0/1, which has the network as internet, right? So this will belong to internet VRF. And then similarly, this LAN would belong to the LAN VR. This is how the basic structure of Versa has been built, right? And then next, so in case if you want internet access to the particular device, so if you want to break out internet locally, so we can use this option to do that. So it will automatically create red tunnels for the direct internet access. And then if you want to build an site-to-site tunnel, that is also possible with this. So next, so in this routing section, so if you want to like have BGP, so we'll be able to configure it here. And if you want to configure OSPF, that is also possible here. So we have BGP, we have OSPF. In case if you want to have a static out, right, we'll be able to configure that. That is the routing part. Then if you want to have any NAT, right, so that is also possible. And then this management services, if you want to integrate NTP server or syslog server, TALX, Radius, So we'll be able to like configure here. And then this is the overview section. So what kind of configuration we have given to the template. So those things we'll be able to see it here. So if you want to like change it also, we'll be able to do that. And then again come back here, and then we have to deploy it. So once deployed, the template will be created here. So we have a branch template. We are having a hub template, right? So once the template is created, we would need to create a device template. So if you go into the devices, I've created three different devices, right? So hub, this is for the hub CPE, this is for the branch 1 CPE, this is for the branch 2 CPE. So if I go into the branch 2 CPE, right? So this is the branch name or the CPE appliance name, and then the device ID is given by the director itself. So it will be an unique ID, the unique ID that will belong to the device, right? And then the serial number of the device, right? So each appliance would be having its own unique serial number, and then this device group. So this is also an important parameter, right? So I've already selected branch -dg, that is a branch device group, right? So when we create add new, right, it will redirect into a add device group view. We'll just give the name to the device group, what organization it is, right? So demo org, and then here is the option where we'll be mapping the template to the device. This is where this device group will map the template to the device. Each appliance would be having a device group, and that device group would be having a corresponding device template. So for example, the branch 1 and branch 2 CP would be having the same device group, and that device group would be having branch template, right? So this is where the branch template will be associated with the device, so that the appliance will know how many WAN interfaces it is using and what kind of WAN it is using, whether we have to give a static IP or if it's a DSAP or not. Okay, that's why this device group significance is more, right? In short, right, the device group is the one which will associate the template to the device. If I click next, so this is where the device is deployed. So wherever the device is deployed, we'll be giving the location information, right? So we can generate the exact location accordingly. And then this service template option, we'll talk about this in detail in forthcoming use cases. But currently for the device template, for the onboarding purpose, this is not needed as of now, right? So we'll just go forward. Bind data. So this bind data is the one where we'll be giving the IP address for the WAN interface, IP address for the LAN interface. This is where we'll be giving. So and then moving forward, the review section. So we'll just double check it. If everything is okay, then we'll deploy it, right? So this is what the device template, right? So if you notice, right, so we have the branch 1 CP which has the branch -dg, so which should have the branch template, correct? And similarly, branch 2 CP would also have the branch -dg. So that means both the appliances, both the branches, branch 1 and branch 2 would be using the same template, that is branch template. And but hub would be using a different template, that is the hub template. This is how you can templatize the appliance details. So in case if there are like 50 appliances or 25 appliances, so it is not necessary to create different templates, right? So if it is using the same configuration, we can use the same template for the 50 appliances itself. So that's how templatization helps in Versa here. Once we have finished creating the post staging template as well as the device template, so we can start the onboarding process. If you can see, so I have taken remote access of the new device. So we'll be able to take OOB or remote access to the new device by configuring the management interface. So each device supports management interface. So we'll be able to take remote access through that. And if you can notice, so this particular branch is running on 22.1.2 GA release. The whole demo environment runs on this 22.1.2 release. Now, so we are going to run this onboarding script onto the device, so that the device will be onboarded into the demo Versa director. So this is the generalized script that we will be using onto each of the branches, so that the device is onboarded successfully into the director. If you can see, we have the org name here, right? So this org name is nothing but the customer's organization, and then we have to specify the controller's WAN IP. The important aspect where the appliance WAN IP should be reachable to the controller's IP. The onboarding would be very feasible. And then if you can see, -s is nothing but the static IP, right? So this WAN IP means the appliance WAN IP. So we'll be specifying the WAN gateway. So the gate. So this is the WAN interface. In case if the appliance has like multiple WAN interface, we can specify which through which WAN interface we would want to onboard. So for example, if you want to onboard the appliance to the MPLS interface, we'll be specifying the MPLS IP, its gateway, and then the interface. So here, so we have VNA 0/0, VNA 0/1, VNA 0/2. If you want to specify WAN interface as VNA 0/0, we'll be specifying it as 0. If it is 0/1, it will be 1. In our case, so I have modified the script according to our demo environment. Okay, so where the organization here is the calculus organization that we have created, and then the controller's IP, this particular IP, we are going to onboard the appliance to internet interface. We have specified in the device template stating that the internet would be DSCP based, -D, which means DSCP. We are going to onboard to the internet interface, which is VNA 0/1. This is the whole summary of the script. Okay, so what I'm going to do is I'm going to copy it into the appliance. Okay, so we have to specify password for it. So it is loaded. Now if you want to check the interface, see the VNA 0/1 got one IP from the DSCP port. We have got the tunnel IP as well. So in some time this will get rebooted. If you see the director, right? You see the appliance is getting created into the directory. It has successfully got created. The appliance will reboot and then it will fully come up here. So if you wait for a few minutes, the device will fully reboot and will come up into the directory. So after the branch got rebooted, once it's fully up, so we are able to see the new branch onto the director. So this is a new branch that we onboarded onto the director. All the branches are of full mesh topologies. All of them would be having SLA between them. If we want to see the IP sessions or IPsec sessions, we can do it to the monitor tab. Under services, if we go to SD-WAN, if we go to sites, we see that branch 2 as local, and we have branch 1 CP, demo controller, and the hub CP. If you want to see the IPsec, so we'll be able to see IPsec. If you want to see the routing table, so if you want to see the LAN routing table, we are able to get the routes from branch 1 and the hub. So now what I would like to demonstrate to you is the LAN to LAN reachability, how the LAN to LAN reachability between CPEs has been established. So we have PCs behind each of the branches. We have a PC behind hub, we have PC behind branch, and PC behind branch 2. We'll check the LAN to LAN reachability part. Now we have the remote access to DC PC, branch 1 PC and branch 2 PC. If I go into the DC PC, so this should have reachability towards the branch 1 CPE and then similarly branch 2 CPE. So I'm able to reach branch 1 LAN and branch 2 LAN from the DC PC. Similarly, I'll be able to ping so from branch 1 PC to branch 2 PC directly. So if I ping 3 dot, so since it is in full mesh, right? So if we check the trace route, this should have direct reachability towards the branch 2 PC. So when I give trace route to 10.1.3.2, which is the branch 2 PC, it goes to the gateway of branch 1 CPE and then directly goes to branch 2 CPE LAN and then to the branch 2 to LAN PC. Now what we'll try to do is, so we'll change the topology into hub and spoke. So making the hub CPE as hub and branch 1 and branch 2 CPE as spokes. We will go back to the director to the template section where we have a section called spoke group. So I've created a spoke group stating that the spoke group type would be spoke to spoke via hub. Previously we have seen that the branch 1 PC can reach branch 2 PC directly. Now what we are going to do is we are going to change the topology into hub and spoke. The spoke PC would reach the other spoke PC through the hub. That is what we are going to do. We have recreated it. We'll go back to the branch template. We will be changing the device type into spoke. We will associate the spoke group here. Nothing changes after this. Redeploy the template. So once it's deployed, and if you see on the hub template, so we have made hub device as hub here. Then we'll go to the devices. Whenever we make changes to the template, we need to redeploy the device again. The changes will be accustomed to the device as well. Now we need to commit the branches. Go to the branch template, fetch devices. Okay, you see there is a template change. This commit template, what it will do is whenever we change something in the template, we need to push those changes into the appliance. We will do the changes to this commit template. So this commit template will make sure that we have the same configuration in the template as well as in the appliance. Select, we commit it. So it is trying to apply template changes to the devices. Now I'll again go to the branch PC. I'll be able to, but when I trace route, so we need to see that it should go via hub and then towards the branch 2 PC. So when I give trace route to the branch 2 PC, so it is going to the branch 1 LAN and then it is going to 10.11.0.4. There is additional one more hop. What is this hop? So when I go back to the director, so you see this 10.11.0.4 corresponding to the TC, the hub CP. All the branches are identified to this management address in overlay. We are able to see the hub management address in the trace route. We can see that the route it is going via hub. There is no direct communication between branch 1 and branch 2. Now we will see one more additional concept, which is the direct internet access. So we have enabled direct internet access in the hub CPE. When I go back to the template, so the hub template in the tunnels, I've enabled DIA or the internet breakout on the LAN routing instance. So if I go back to the hub PC, I should be able to ping internet and browse internet content. I'm able to ping internet. So let me check if I'm able to resolve Google. Yes, I'm able to do that. And then if I try to browse content, so let me try with Google. I'm able to access Google. I hope that the demo was very informative and practical for you guys. I hope to see you all in the next video. We'll be coming back with more videos and training. Please stay tuned.
Thanks, Rahim, for the great demo. I hope it was useful for you guys. Now, to wrap it up, SD-WAN is a groundbreaking technology that offers agility, security, cost effectiveness in managing modern networks. Its ability to adapt to changing network conditions and optimizing performance is a game changer for business of all sizes. That's a wrap for today. If you found this video helpful, don't forget to like, share, and subscribe. Thanks for watching and see you in the next one.